Hello guys, greetings from India again. This is Nirbhay Chauhan from Eklavya Self-Learning Tutorials. Well guys, we were live basically an hour or two ago, and we were doing generative design in FreeCAD basically, and we faced some issue, and the issue was basically around the folder structure. So this is a folder live session, and there was a space in between, and now we have an underscore. That was the reason uh, our recurring analysis were not running, and I basically figured it out. And if in case you guys are here, if anybody is back again, feel free to just drop a hi, right? And if you're a new user, basically a new member, and you are just seeing this thing for first time, just drop a hello, right? So we'll quickly start. In this session, basically, we wanted to discuss around generative design and topology optimization inside FreeCAD, right? And for that, basically, there's a macro, which is BESO, right? I'll just tell you how you can basically install that also, right? So here, if I just show you, I'll just drop the link also for this macro in the comments and description of the video, right? Let me just drop it now only. Macro link, right? So this is the macro basically which we want to use and will be using in this tutorial also, which is for the BESO, which is bidirectional evolutionary structural optimization. So it's a Python based macro using Calculix FEM solver, right? You can use it for your part design optimization, any furniture design, any small parts, or maybe your civil engineering projects, right, which we'll be doing it today, right guys? So you can use it to enhance the optimization and get a good geometry. So like here you can see we have a, you can say, box girder bridge, rectangular bridge basically. Here the vehicles will be moving, and these are two endpoints, you can say two roads which we have, right? So this rectangular geometry we want to optimize, right? So how the steps are very simple. We have this geometry modeled, right? So guys, if in case you are in between the live, just feel free to drop a hi. I am just seeing your chat also simultaneously. It really motivates me to basically interact with you guys, right? Okay, so now what we'll do is we go to FEM workbench here, right? And we start with an analysis container. We define a material. Let's say for this one we are going with Calculix steel and click OK. Then let me just hide these roads, okay, because this is a geometry which we want to optimize. Now we will constrain the endpoints using this fixed boundary condition. We'll click on add, and this is the edge which we want to fix, right? And this one, cool. Click on OK, and now we will define the load, which is this one. This should be 400,000, which is 400 kilonewtons. Click on add, and this is surface. The direction is upward. Let's click on reverse direction, right? Now it is downwards. We click on OK, and now we have the load also applied. As this is heavy object, it's a bridge, so self weight is also important, and this is the gravity load which we can apply simply, and this will be added right into downward directions, right? So we have the material, we have the fixed constraint, we have the force, we have the self weight, and now basically we want is a mesh, right? You can use NetGen mesh also, right? Or you can use Gmesh. So we can select the object, we'll go with the Gmesh. Element dimension, element order, like we are fine with now, but the element size you can give around 2000 mm as maximum and 1000 as minimum. So you can reduce it as much as you like, basically as per your needs, and you can make it as much finer as you want. More finer is your mesh, the more accurate results you will get, right? But it will also take more time. So you need to like maintain a balance. So if in case you have the time and you can be with that, so you can basically go with the finer mesh. We are going with this amount of granularity here, considering this is an example, right? We'll hide our slab, and this is the mesh that we have got. Now you can run analysis on it, right, which is optional, just to check that your results are getting fine. I'll just show you quickly the analysis also, right? We click on solver tools, we go to solve, we choose a solver job control, right? Now make sure this path that we have, this need to change, and we'll go to desktop and live session, and here is our FreeCAD file also, and this is where we want this INP file to be there. The reason being, when we'll run our macro for generative design and topology optimization, this is the INP file which will be fetched, and there the recurring analysis will be performed, and your new INP files would be generated there as per the iterations, right? So that you can fetch that easily. We need that folder location very well. That's why we have changed the folder location here. Now we'll click on write INP file, right? INP file is created. You can start your macro from here also, but let us just show you the results also, if in case you want to be very sure. So click on solver tools, go to solve, run solver calculations, right? So this is just for reference, if in case you just want to see your analysis results on your object, right? So this will just take some while depending upon the complexity of the mesh and the object. And here you have the results. We click on show result. Displacement magnitude 6.12 mm. We can just see it also, the displacement. Let me just hide the pipeline results. Yeah, now it should be fine. You can see your results, guys, right, as per your need. This is quite okay. Cool. Now the thing is, INP file is well written. I can just show you in the folder. This is INP file, this is analysis file, and this will be used for recurring purposes now. So what we will do is, so if you guys you are seeing it tutorial, just feel free to drop me a hi there. I am here for you. Okay. So now what we will do is, we select our macro, and here make sure where the macro is extracted. So you can download this macro basically, if I just haven't shown you. So this macro here with the option of download as zip, you can download it wherever you want inside your local repository, right? You can extract it, and then basically in FreeCAD, this is a folder. You can see BESO master, and this is the folder where you have to stop and say a select folder, and all your py files will be shown. Now we will have to set this second one, which is BESO underscore fc underscore GUI dot py macro, right? We'll execute this, and you will get this user interface. Need not to like get more into complexity of this. We'll choose the option that basically we're interested in, and which would eventually solve our issue also. So first thing is we select the analysis file. So this is the analysis file which we have just created, guys. So which is lying on our desktop. It usually is fetched automatically. The reason is we didn't do that. Let me just copy this path, and this is a file that basically we want to use. Click on open. Everything is fine here. Changes per iteration we can keep in between, like how much change we expect in the meshes while the iterations are proceeding. Mass goal ratio, this basically means how much percentage of the mass would be left. So it is 0.4 means 40% of the mass would be remaining at the end of analysis. If it's 0.8, that means 20% of the mass would be removed and 80% would be remaining. Here basically you can go with 0.5, like 50% reduction. Okay. um, and then we can click on generate configuration file and run optimization. This is the final step, so we'll do it now. Now basically using that INP file, it will start running the iterations automatically. You need not to do it manually, opening it again and again. It will just open two graphs here. Okay, and I'll just tell you the meanings of it also. Guys, just feel free to drop me a hello if in case you guys are watching. It really helps me to interact with you. It's really nice. Okay, so it will show a graph here, like this one. So the first one is mean energy density weighted by element mass. So we can just scroll it here. And this is the second one, which is the mass of optimization domains, right? As we have set the goal of 0.5, right? And now these are the iteration, like one iteration has been done, right? It will do couple of iterations. So how do we know when the results are done? This graph would basically, as you can see, it is quite steeper now. This will get parallel to the x-axis, right? And then it would stop. And if you see the folder here, you can see the INP files are getting generated automatically, right? It's 03 iteration, it will go to 04, 05, around 70 to 80 iterations would be done for this. So it will take around, like, maybe I should say 10 minutes, 10 to 15 minutes, depending on the complexity, and eventually it will stop, and it would give you the INP file in which we are interested in finally for the optimized shape. If in case you guys are watching it live, you can grab a coffee, right? Because it will gonna take a while, right? We are into third iteration now. Feel free to grab a coffee. If in case you're watching it afterwards, means this session is recorded and uploaded, so you can feel free to skip it and to 10 minutes around, and you can see the final step where we are interested in, right? So meanwhile, let this run, right? You can see this ratio would start reducing, and it will reach to around 0.5 as we have given it, right? Similarly, this mean energy density weighted by element mass would also get like parallel to x-axis as it will proceed to the iterations. 5 iterations have proceeded, right? Guys, feel free to share this if in case you see this is helpful to your friends and colleagues, and because this is something interesting whenever, like, we are into the initial phase of designing and we want to see how our the shape has to be there, and where we can save the mass or the material for the overall geometry. It's very beneficial, like whenever you are designing a chair, or let's say a part or a hanger or a bracket, like there are n number of applications to it. So it basically gives a kind of high level initial intuition, like, okay, this is a geometry that eventually has to be created or modeled, right? And it basically saves our time for reiterative designing or analysis. So if we see 8 iterations have passed. Cool. It's gonna take a while, so just bear with me, have some patience. Meanwhile, guys, feel free to just drop any comment in the chat section, anything you guys think of, and where are you from, where are you situated in which country. I am from India, from Punjab. So the world is getting shrink day by day, it's getting very small. We all guys are connected to each other, and this is something really exciting. Feel free to like the video, share it. Just drop a chat, drop something in the chat, guys, else we'll get bored. because these iterations gonna take some time. You can see the folder here, the files are getting generated. 11th, we're into 11th iteration now, right? So just let it run, you need to stop anywhere, don't do anything. This loader will eventually get resolved, and you can see in this video also the things will be fine, and that's when your results are done. In terms of feedback to community, like the one issue which we figured out while we were live before, which really messed up my mind, but it was the very simple issue, that was it doesn't accept spaces in the directory for the file where your INP is situated in. So usually I don't give spaces, I use underscore, but sometimes any user can do that mistakenly, and anyways there could be folder structure which could have spaces. So I think if that could be improved, that would really be helpful. Otherwise users gonna stuck in between, and they had to change their whole folder structure and the renaming, all that stuff, right? Other thing is, if this feature, this macro can be made part of core FreeCAD, so that users need not to like download it on their own, and they can directly use it within FreeCAD, right? That will be something really helpful. Uh, and if you guys think this is helpful, like, feel free to comment also. That should be great. Meanwhile, let me just share this on Twitter. Right? Maybe if in case the community anybody wants to join. So we can say come join. Okay. So I can post it. Guys, I'm waiting for your comments. I know you are there, but just in the previous live session, like, we had like good discussion, but eventually there was that issue which really messed up the things, and I'm doing this live again. But okay, these glitches happen, and that's how basically we learn. I think that will be really helpful for others also who might have faced that kind of issue. The iterations are running. This should take a while, like maybe 10 more minutes, but that it is like worth waiting. It's really nice to see the results. What else, guys? You can let me know in the comments, like, what kind of projects are you currently working on in FreeCAD. like what kind of projects are you currently working on and what kind of workbench do you usually work on, and we can discuss such things. So where have we reached? 20 plus iterations. Okay, cool. So you can see INP files are getting created. 22 INP files. But we need more, like till our best results are created, right? That is something that we will use for our project. So these iterations take a while, as I've already mentioned. I'm just mentioning if in case any new users are joining in, so just for their purpose. But yeah, this is worth saying. But meanwhile, we can discuss on the chat, else like you guys might get bored. In terms of structure analysis, like things are really progressing fine. There are a couple of workbenches, like I am looking forward to it. There is one for structural tools that's also on top of FEM for 2D 1D elements, and I think that's currently in progress. The alpha release for that workbench is like yet to come. Even I am waiting to test that. It'll be great to see. Inside BIM, a lot of improvements have been going. Tech draw is there in terms of good dimensioning, and I think overall things are taking good shape. The previous live like went very well, but eventually at the analysis these graphs were empty, and I was just like, oh my god, what happened? The good part was like discussions were happening really well with the audience. The people were interacting, like they were mentioning their comments and concerns. That engagement basically is something really nice, and people from different countries and different backgrounds like come to interact with each other, and that's something like very nice, the kind of human touch that we can see. Yeah, so I was saying the live went very well, but eventually the issue basically I was not able to figure out like what's happening. Maybe my analysis is wrong, or maybe some constraint is wrong, right? I was just trying to just revisit everything. Eventually it was the directory spacing issue. The space should not be there in the folder names or file name, and as I mentioned earlier, in a folder name called live session there was a space, and this macro uh, faces issue if in case spaces are there. I think that's a very common mistake that could happen because people do use spaces in their folder structure. Developers have camel casing underscores. Even I use underscores in my folder structures most of the time. I think this was very rare case when underscore thing was not there. But yes, eventually doing this mistake unknowingly we got to know a kind of bug, right, or a kind of issue which is there in this macro, I think, which needs attention, right? Otherwise, people might not be able to figure out. Even we were stuck very badly, and it was really embarrassing that we are live and we are seeing such issue happening, you know. So that's the thing basically, which basically it sometimes makes us or brings us in a bad situation. But anyways, sooner or later we were able to resolve it, and now we're able to see the graphs and the analysis is running. The results like are really nice. When you see the results, na, the mesh, the optimized mesh, right? That's something really nice to see. And guys, one more thing, like if in case you're watching it, or maybe you're watching it later, when live is finished, you're watching it in your free time. What do you guys like? What do you guys like prefer? Live sessions or pre-recorded sessions? Or like mix of both? Mix of both anyways we are doing, but what do you prefer like more from these? Live sessions make you more interested, or is it the pre-recorded session? What issue like do I see here is in live sessions sometimes we can end up in some unwanted or unthoughtful issue, right? And it gets very sometimes strange to resolve that issue during the live session itself. Pre-recorded sessions have their own pros and cons, right? The pros is you can go well prepared, and if in case there are issues you can re-record and document the issue, right? Even in live session we can definitely document that. The pros of live sessions is like we get to interact with the audience uh, as we are progressing or we are getting larger with the audience, and the interaction is something really helps. It keeps you engaged and tied up with the people, and if in case there are any issues, like we get to know. Sometimes we may face some different issues, and other user may have some different issues basically, and that's the kind of eventual collaboration which basically helps us to improve our usage, right? So if you see the folder, how many iterations, like it's 44. So 44 files you see have been generated and analyzed and generated automatically. You can see these are getting created automatically here, right? 45 have been done. There's still time in this because this graph is currently steep, but it will get totally flat, parallel to x-axis basically. And here you can see the ratio, it's 1.4. It will reach till 0.5 as the goal we have set for our file basically, right? So that's what it is trying to do. You can see it started getting flatter now. So we are very near now, stay tuned, right? So if in case you went for a coffee or something, I think you should get back now. We are quite near to get our final results. But still guys, I have not heard anything from you in the chat box. You can just say a hi, hello, don't be shy. or maybe you want to keep your identity a little bit private, but that's okay, no issues. So it's getting flatter and flatter. That's something basically we want to achieve as a goal for this. Currently here in India it's getting quite hotter now. Summers are coming. It's the month of end of March now, but yeah, usually March is quite hotter, but the kind of weather that we have now is like comparable to June. Like it's getting very hot. What kind of weather is there in your respective countries or cities, guys? Like, feel free to let me know. That's how like we'll build a community and interaction with each other. So 50th iteration it has reached. If you see the files, yeah, 51 files, yeah. So it's getting near, but it's still working, right? Because this judgment you get as you're scrolling your mouse, you can see here the x and y axis which is showing on the top. It is not yet very smoother. That means there is some progress going on. So I think another feedback could be here is a kind of progress bar, or you could say there should be something like that that should make user aware that my iterations have been completed. Because currently also you see it is flatline, but I know the iterations are not yet completed, right? Because it's not yet that smoother in terms of my mouse movement. So that's the idea which basically currently I can get. Another idea is your file generation would basically stop inside your folder, right, where you have your INP files being created. So they're basically but we are quite near to what we want to achieve. I think just couple of more minutes now. I think we are almost done. So good things like takes a bit of time, but eventually worth waiting for. Is it done? I think you can see mouse movement at top is quite quicker. Let us just see the file creations. It has done 57 iterations, 57 INP files. To me it looks like we are done. Yep. Okay, so you can see this graph is also quite straight now. Okay, we can close these files. Let me hide this mesh also. So now guys, what we'll do is we simply have to copy the last INP file created with the state 1. So you can see file 057, state 0, 51 and 57 and state 1. So this is the state 1 57 file, the last iteration which we're interested in. Simply copy it, Control C, right? And now go to your FreeCAD and inside it simply right click anywhere in the project and click paste. So you can see this is the optimized geometry that we have, voila, right? So it's not very even, but it gives you a kind of idea, the initial idea that how your geometry gonna look. So if you just see the transparency, this was the original slab, your original box cutter. Let me make it transparent. Guys, if in case you're finding it helpful, just hit like button guys, it really motivates. And anyways, so you can see how much space like the material has been reduced, has been eradicated by the program, right? And this is the final geometry that eventually we are interested in. So what we'll do is, let me hide this slab, and now what we will do is, let me also hide these constraints and everything. So eventually we want to model our geometry simply by tracing on top of it. So it's very straightforward. So what we'll do is, let me unhide these supports. Okay, firstly let me just draw the road connecting with this, which is a slab. Let's go to BIM workbench. So quickly model this, it should not take much time, right? Let us just switch our workbench, click on this and switch workbench to this one, this surface, and let me just hide it for a while, and we'll draw a rectangle on here. So draft object rectangle, this is the point until here. Okay, this is the surface that we have got, and we'll click on slab object, and the height we can give around, the height 1000 mm. Right guys, I hope you guys are with me. Now the thing is, this we have drawn. Now basically we want to trace the arch and the bridge geometry basically. This is very simple. So if in case you see, this is a kind of inverted A here, so you can get a kind of, this is how it is going, then straight, and then this, and then these two arches like this, right? So that's how the bridge has gone, and in between these inverted A shape, right? So what we can do quickly, let me just click on this surface, and this is the plane on which we want to work on. Click on the sketcher and we'll draw simply sketches here, right? So just draw approximate sketches, right? What you can do here is, let's just constrain the geometry. The reference that we want is this one. Okay, click on section view, and now from here let us just draw geometry starting from here to here, very roughly, right? And from here let it be straight line like this, right? You can draw arches, but I think this would work till here, like this, right? Sorry, I got a sneeze, little bit of cold, I'm recovering. Now thing is, you see, this analysis is fine, but it is not very even. Eventually it should be even, because the loads were even, the distance between the supports is even, the shape was even. But anyways, it has shown us this geometry, so but we can do the optimization on our human judgment as well, right? So what would happen here is, this we can constrain as equity, means they will expand in both the directions equally, so you can keep it somewhere like here, right, till this extreme edge. This edge and this edge we can make equal, right? Similarly, what else we have? This is fine, I guess. Let's first give the length for this side. So this should be okay with 4000 mm, like this. This height basically we need to give, okay? So this can be from here to this point. This is the something we want. This should be 9000 mm approximate. Okay, what else we are left here with this, and that is this length, right? So this we can give, simply click on this side. So this is 36.70 meters. If we make it 36 meters, yeah, this should be fine. Okay, so this sketch is constrained, but not yet. We need some more geometry here. Now what you can do, draw again this polyline. Start from this point, go till here, and that's how basically we need our, you can just rotate also. Yeah, that's how you can, so till here we need a geometry like this point, right? And till here. Okay, so this is the point that we have got, and then so if you just do it like this one, right? So it's little bit approximate, but yeah, eventually it helps. Go it like this, this, and then the rest is symmetry basically. Cool. Okay, so we have got this rough sketch of the truss. Let us just make the things equal wherever required. The first thing is this point, it has landed up on a bad place, on a bad point basically. I need to remove this constraint. It's not letting it. Wait. This is the one, constraint 19. I'll just simply delete it. Yep, this is good. I want to constrain it on this line, not the point. Now it is good. We can make equity constraint between this axis, this point. Okay, similarly for this one, because the trusses go in symmetry usually, most of the time, and this was the issue, it was not working. Then what we can do, I think this also would be in the equity manner. Very fine. We can do this length to this length as equal, so this would be approximately, so this can be 9500 mm. Okay, this is done. Then this one, okay, it's not behaving right. Okay, this length and this length has to be equal, and these lengths can be 3500. Okay, this makes it better. Another length now in which we are interested in is these ones are left now, their heights. So how you can adjust their height is, it's very simple trick. Click on this point and then this line basically, guys, and simply click on constant constraint. Okay, same, let us just, this is already fine. Okay, cool. And this height basically we can give, so just select any points like this one and this one, and this is the vertical height. So this has to be somewhere around 5600. Just getting the idea, right? This is done, and now either you can give length of this side overall or the gaps here. Let me just give the length of this side overall, which is coming around 15 meter is fine, guys, right? We exit the sketch. Let me just hide this geometry. So this is sketch that you have got, guys. If I'm not wrong, this is even from both the sides very well. Now what you can do is select on the sketch, we can extrude it. So the direction I am just thinking where it is. It has to be negative y direction. It has taken 1 by all, but yeah. And along 1000 mm, create solid, click on apply and close. So you can see you have got the truss, the one truss basically, as per the geometry that we have seen there. Are you guys there still? I can see. Great. Let me know if in case you have any doubt. Now what you can do is let me just switch to this view and click on top, and we'll simply clone this. Click on this extrude, or what you can do is yeah, we will clone it, and here is the clone option, and it's asking the position to copy from here. Like this. You will click on escape key, and now you have both of your trusses ready and they are with you. This is, guys, basically so far that we have seen. Now you can create these extrudes into, let's say, structures. Let's say these are beams. This one is also, let's say. So it's totally up to you how basically you want to see, or what kind of property do you want to assign to your structure. And now if you see the original geometry, this was the original geometry, which is transparent, and you see how much weight and the material has gone, reduced from it, right? And this was our final INP file, and you can see we have modeled it very closely to it, right? So guys, this was it in this session which I want to share with you guys, and I thought it was something helpful and could be used in civil engineering projects and smaller parts, brackets, chairs, tables, and all that stuff, right? And I think this was it for today. If in case you guys like the session, let me know with your comments, right? Share it with your friends, hit the like button, and let me know for suggestions what else you like to see in coming up next. And if in case you find it helpful, like I have a page on coffee, the link is also there in description, like feel free to buy me a coffee there, it really motivates, right guys? So we'll end up here. Till then, take care, goodbye, see you in next video guys. Thank you so much.